So if you're in chemistry and taking organic, the first thing you're looking at is alkanes, alkenes, and alkynes. So I'm just going over a lesson to name and draw them. So we're looking at all line diagrams here. So if you're uncomfortable with line diagrams, we can also go through that. And starting with numbering our first one, you want to recognize that this chain is your longest chain full of carbons. And we want to number our carbons, in this case, from right to left, because we want to give the smallest side group the smallest number possible. So that would put it on carbon 2. Instead, if we went left to right, it would have been on carbon 4. So smallest being 2. So we've named this 2. That is a methyl group. And then your longest chain is pent. And then it ends in ANE because it's all single bonds. The other part you want to know here is because it's all single bonds, this would be a saturated hydrocarbon. The next one, I'm going to number from left to right to give the smallest methyl group on carbon 2 once more. So this would be 2-methyl, and then 4 carbons would be bute, and then ending in ANE for all single bonds. This next one, number 3, we don't have any side groups. It's just 4 carbons, 1, 2, 3, 4, and this would just be butane. Number 4 is an exception to the rule that we don't have to say where our methyl group is. Because this is a 3-carbon chain, it can only be on carbon 2. So this would be methyl, and then 3 is prop. So propane, propane for all single bonds. My very last one here, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 in my longest chain. And then attached to carbon 4, we have 1, 2, 3 carbons. So that would be a propyl group. And then 9 would be non. And then ANE for all single bonds. Going the other way, if you have the name being able to draw, then I will stick with drawing all line diagrams just because it's faster, and that's what this worksheet was doing. So I always start with the root pentane. So we want 5 carbons, 1, 2, 3, 4, 5, and on carbon 2, a methyl group. This next one, heptane, is 7 carbons. So starting at carbon 1, 2, 3, 4, 5, 6, 7. On carbon 2, 3, and 4, you have methyl groups. And then I always say it doesn't matter if you go up or down, you just have to make sure it's on the right carbon possible, or right carbon, and that it's, this has to be on carbon 2. If it went down, it would still be on carbon 2. This last one, not the last one, the third one, non-ane, that is 9 carbons. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then putting those side groups on carbon 4, a butyl group. So 1, 2, 3, 4. Butyl means you have 4 carbons. So 1, 2, 3, 4. Right, 1, 2, 3, 4. On carbon 6, you have an ethyl group. So 2 carbons. And then on carbon 2 and 5, you have methyl groups. Octane is just an 8-carbon chain. So 1, 2, 3, 4, 5, 6, 7, 8. And this last one, 2, 3, dimethyl butane. Butane is 4. 1, 2, 3, 4. And on carbon 2 and 3, you have your methyl groups. So that is alkanes. Moving on to alkenes, you want it to end in ENE. And you always want the chain to start with the lowest number possible containing the double bond. So I'm going to number this one from right to left. But it actually wouldn't matter because it's just 3 carbons. So if we went the other way, it would still be between 1 and 2 if we just flipped the molecule. So this one would just be propene. The next one, numbering, this one for sure has to be from right to left. And your double bond is between 2 and 3. So this is pent. And then number 2, ene. This next one, 1, 2, 3, 4, 5, 6, numbering from left to right to give the smallest number possible for your double bond. And that's 6 of them, so hex, 1, ene. The next one here, finding your longest chain, 1, 2, 3, 4, 5. So it doesn't have to be in a straight line, just a longest continuous amount. And then on carbon 2 and 3, you have methyl groups. So this would be 2, 3, 3. Then dimethyl, your longest chain is pent. And then between carbon 2 and 3, so carbon 2, ENE for your double bond. Again, finding your longest chain, we have 1, 2, 3, 4, 5, 6, 7, 8. And with your longest chain, it must contain the double bond. And then we go through this. So on carbon 3 and 4, you have ethyl groups, and 5 and 6, you have methyl groups. So alphabetically, E comes before M, so we're going to name those first. So 3, 4, dimethyl, and then 5, 6, this should have been ethyl. Diethyl, then dimethyl. Right, so again, alphabetically, E comes before M, so that goes first. And then 8 is oct. It's between 2 and 3, so 2, ENE. Moving on to drawing. Now this worksheet that I got this off, they name it a little bit different than what you see. They're putting where the double bond is located in front of the root instead of in between. So that's fine, we can still do that. This first one, pentene, we know it's 5 carbons in our longest chain. So 1, 2, 3, 4, 5. Between carbon 1 and 2 would have your double bond. And on carbon 2, you have a methyl group. 2, butene. So butene is 4, 1, 2, 3, 4. And between 2 and 3, you have your double bond based on that number 2. Pentene with number 2. Pent is 5. So 1, 2, 3, 4, 5. And then between 2 and 3 is your double bond. And then on carbon 3, you also have an ethyl group. I took the last 2 off because in high school chem in Alberta, we don't look at this other naming, like with trans and cis. In high school, or in Alberta, you don't do that until university. So we'll just skip those 2. Okay, so now that we've done that, we can look at triple bonds. Triple bonds always will form a linear structure, and we still want to find the longest chain that contains that triple bond. So I'm going to start numbering from here. So 1, 2, 3, 4, 5. So again, we want to know that that triple bond, because it's linear, it's still showing it. We just have to make sure we know that there's a carbon on either side. So this would just be pent, and then between carbon 2 and 3, 2, and then YNE to show a triple bond. If I do this next one, 1, 2, 3, 4, 5, 6. So on carbon 4, you have 2 methyl groups. So 4, 4, dimethyl. And then 6 is hex between carbon 2 and 3. And then YNE for your triple bond. Number 3, you have 1, 2, 3. Because your triple bond could always only go between 1 and 2, whether this molecule was flipped or not, this would just be prop YNE, so propine. Looking at this next one, just again, finding your longest chain possible. 5, 6, 7, 8, 9. We're going up. And between carbon 4 and 5 is your triple bond. But on carbon 2, you have a methyl group. And on carbon 6, you have an ethyl group. So we'll name ethyl first because it's alphabetically first. And then on carbon 2, you have your methyl. 9 in your longest chain is non, and then 4 because it's in between 4 and 5, and YNE. So this last one that's thrown in there to name, there is no triple bond, but we do have a ring, so we'll have to see the name cyclo, and you have a methyl and an ethyl group on there. So we'll have that on carbon 1 and 3. For carbon 1, ethyl will be named first, so this would be 1 ethyl. And then you would have 3 methyl. Because it's a ring, you want to put the word cyclo. And then 4 would be but, all single bonds, ANE. Going to do some drawing. 3 heptine. Again, this is just the format of this worksheet. The 3 means it's between 3 and 4. Hep means 7. So 1, 2, 3, 4, 5, 6, 7. Putting it between 3 and 4. We'll put that triple bond because it ends in YNE. Pent is 5, so 1, 2, 3, 4, 5. Between 2 and 3, you have your triple bond. With this video, it just kind of cut out on me, so I'm looking at YNE. So non is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Between carbon 1 and 2 would be your triple bond. And then we have lots going on here. So we have on carbon 3, 4, and 6 ethyl groups. So 1, 2, 3 is an ethyl group. 4 is here, and 6 is another one. And then on carbon 5, you have a methyl, and on carbon 7, you have a methyl. And then that one's done. And then number 21 here, this last one, 4-octine. Oct is 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then in between carbon 4 and 5, you have your triple bond. Lastly, just talking about boiling points. When you're comparing, so say we were comparing, let's go with just ethane. This would be ethane. So ethane compared to, if you had that double bond between the two, this would be ethene. And then the last one would be ethyne in terms of, that looks weird, sorry. Y-N-E. In terms of a double and triple bonds. So with this first one, when it comes to boiling points, it doesn't take much energy to break apart a single bond in terms of there's no other force other than LDF. When it comes to the next one, because you are putting in a double bond, which would have less electrons, it would take even less energy, and this double bond would be easy to break. So that one actually would be able to have a lower boiling point than ethane. And then the last one, because of the linear structure, so this one wouldn't actually be linear because we have those hydrogens sticking out. But this last one, your hydrogens that are attached all form a linear structure, and that means they can really pack close together. And because of that, this has the highest boiling point. So when you're comparing boiling points, it goes ENE, then ANE, and then YNE. So double bonds have the lowest boiling point, single bonds are in the middle, triple bonds are last. As always, I hope you found this helpful. If you did, please subscribe, and please check out my website. It has all the lessons from chemistry, and in any area you might need help with, you can just take a look at that. Thanks for watching.